All right, guys, we're going to take a look at limits involving infinity. So, like, for example, if you look at 5 over x plus 3, let's take a look at this kind of visually for a minute. You know, this thing's got a vertical asymptote at -3. Right, and if you plug some points in, like 0, give you 5/3, and you know, you could plug in some other points, but you kind of look like this. You know, plug in like -4, and you get -5, and so on, right? Anyways, you kind of get to look at your graph, and let's do this visually first before we get into this, and then I'm going to show you that, hey, you don't need to graph every function when you're talking about these. One-sided is including one-sided. So if we go to -3 from the left, right? So we're approaching -3 from the left, right? So I'm following it down. I'm noticing, oh, do I have a limit? It's shooting me down. Do I have a limit? No, yeah, I say no limit. But what we're going to do is we're going to describe it. So please recognize it is not getting arbitrarily close to a value, but I'm going to describe it, what it's doing. So I'm describing the behavior. Well, it's shooting me to negative infinity. That's what it's doing. So I'm going to answer that as negative infinity now. If I'm approaching -3 now from the right, right? So now I'm approaching it from the right, and I'm like, oh, it's shooting me up if I'm approaching -3 from the right. Does the limit exist? No, there's no limit. Again, I'm not getting arbitrarily close to anything, but I'm going to describe it, and I'm going to say it shoots to infinity on that. And then overall, do they agree? Well, one shoots it to negative infinity from the left side, one shoots it to positive infinity from the right side. Do they agree? No. So then on the last one, I say, well, limit does not exist. Okay. If they would have agreed, like both of them are shooting them up to positive infinity from both sides, then I would have said, sure, the limit doesn't exist, but I'm still going to answer it as infinity if they both shoot up or if they both shoot down. So there's a visual look at that. And now let's actually do it with values. So if we are approaching -3 from the left, and I plug in some points on this 5 over x plus 3. Here, let me do it with my decimals here. And let me do a little table of values. So I'm going to approach, let me put my -3 down here. I know it's not defined, but let me get closer and closer to -3. So I'll start with -3.1, get a little closer, -3.01. Let me get a little closer, -3.001. Again, I'm approaching it for -3 from the left. As I mess this up. And hopefully you can see, gosh, if I just throw in something really close to -3 on the left-hand side of it, I can see that that thing, like it's, what's the y value doing there? Shooting it down, right? I got this -500,000, right? If I get even closer to -3 from the left, it'll shoot it even further down. Does that make sense? That's how I know it's shooting it to negative infinity, because I'm approaching it from the left. Now, if I do the same thing, but I approach -3 from the right, let me erase all this. -3 from the right. So let's say we have 3.1. Get a little closer to 3.01. Get a little closer to 3.001. And what's the behavior of this thing? And you're like, oh, it's shooting it. Oh, for the love. Thank you. Appreciate that. That definitely makes a difference. Oh my gosh, what am I doing? I'm approaching it from the right. I'm so sorry, guys. From the right hand side. If I'm on the right, that would be like, let me do like negative 2.5. A little closer to negative 3. How about negative 2.9? A little closer to 3. And 2.99. 2.999. Boy, I really screwed this up, didn't I? Anyways, you keep going with the 9s, right? Hopefully you see, oh yeah, this thing's shooting it up, right? As I get closer to negative 3 from the right, right? So you can plug values in. Let's take a look at this one here. If we're going to approach 1 from the right, and let's say we, again, let's say we do this, but we're going to do it without drawing a graph, right? Let's test a value. We're approaching 1 from the right, so give me something really close to 1 from the right. So 1.0001, let's say, right? And I throw it in. So 2 plus 1.0001 over 1 minus 1.0001, and you'll get 3001, and hopefully you conclude that this thing is shooting it to infinity. Right? Let's look at the graph. I got x plus 2. I got negative x plus 1, right? So I've got this vertical asymptote at x equals 1. I've got a horizontal asymptote of, negative 1. And of course, I just plug points in. You see this, right? So as you approach 1 from the right, I'm approaching that 1, which I have that, it's undefined, right? I have a vertical asymptote there, so it's shooting me down to negative infinity. Does the limit exist? Nope. Technically, the limit still does not exist, but we are describing it. That's all we're doing in this section. We're describing it. It's shooting it to negative infinity. Let's do this one. I'm going to approach, and again, notice I'm going to 0, right? This thing's undefined. I know I have a vertical asymptote here at 0. That's the whole issue with this. But can I test a value? Well, yeah, sure. Let's test something. 0 from the left. 0 from the left. So let's do like really close to 0 on the left of it, like negative 0.0001. And so you plug that in, negative 0.0001 squared minus 1 over negative 0.0001. And that'll get you 10,000. So hopefully you conclude, well, the limit does not exist, but this thing's going to shoot me up. I could check another point if I wanted to and get something even closer to 0 from the left. But if you graph this, it'd have that vertical asymptote, and it's going to kind of look like this. It's kind of an interesting looking one, but we're approaching 0 from the left, right? So we're approaching it from the left, and you notice it's shooting it up, right? Shooting it up there from the left. All right, this one you notice if I plugged in cosine of pi halves. Cosine of pi halves 0, can't divide by 0, right? So we got another problem here because if we were actually graphing this, we would have a bunch of vertical asymptotes at like pi halves, 3 pi halves, and so on, negative pi halves, negative 3 pi halves. If you're graphing negative 2 secant of x or negative 2 over the cosine of x. But we're going to approach pi halves from the right. So approach pi halves from the right. Well, pi halves, if you punch pi halves in, that's like 1.570796, right? So let's approach it from the right. So let's do like, little bit bigger than that. Let's use like 1.571. And so now we're just plugging that in. -2 over the cosine of 1.571. Let's see what that gives us. Pull the decimals here. And I should be in radians, not degrees. There we go. Make sure you're in radians there. You get 98.19.652. And again, if you did a little closer, you'd shoot up even higher, right? So that's a big number, big value. Let's go ahead and write that back in here. So you conclude that thing's shooting you to infinity. Of course, if you graph that at pi halves, got an asymptote. Three pi halves, you have an asymptote. And so as you approach pi halves, let me do a few more here. Anyways, kind of repeats this pattern. But as we approach pi halves from the right, I'm approaching it from the right. Can you see in red there? That thing's shooting me up, right, visually. So I punched in something just to the right of pi halves. So I can see it, which way it's shooting me up with that vertical asymptote, right? Well, this one, the nice thing is if I plug the 4 in, what happens? This thing's defined. That's not a problem. All right, so I got 16 over 32, so I got 1/2. So the limit as x approaches 4 from the left is 1/2. It'll agree from the right as well, won't it? But as we approach 4 from the left, it'll just spit out 1/2. This one, I'd probably factor this first instead of just plugging it in right away. I got -1/2 from the right. So I factor that 6x squared plus x minus 1. So that'd be 3x minus 1. I'd have a 2x plus 1. And see how if we plugged in -1/2, it's going to give us a problem there. We're going to be dividing by 0. And why is that? Well, see how these cancel? That's because I have a hole at x being -1/2. If they cancel, right? This is a rational function. I have a hole. So I have a removable discontinuity. So why don't we just rewrite it as the simplified version? Because it behaves like this one, the simplified form, but the simplified form doesn't have a hole in it. And I get arbitrarily close to the hole anyways, right? That's where my limit's going to be. So let's throw it in. So I get 3 times -1/2 minus 1 over 2 times -1/2 minus 3. So I get -3/2 minus 1 over -1 minus 3. So -5/2 over -4. So I got, what's that, 5/8? So I got 5/8. That ends up being 5/8. There. All right, again, it approached. If you would have graphed this, you would have still had at 1.5 or 3/2, you still have the vertical asymptote. But at -1/2, it had. I didn't draw that very good. I had a hole there, right? But I do have a limit. So -1/2, 5/8. So let's take a look at some infinite limits here. I want you to note this. You know, if you have any sort of constant on the top, let's say it's just like 2 over, let's just make it x, but and it's just got to be positive there. If you think about this, as x gets increasingly large, right? I put in 10, I get 2 tenths. I put in 100, 2 100s. I put in 1,000, 2 1,000s. Put in 10,000, 2 over 10,000. Anyways, what's the value doing? It's getting closer and closer and closer to 0, right? Because this bottom number is so big. It's so much bigger than the top, right? It just gets bigger, closer and closer and closer and closer to 0, right? So anytime, you could sum this up, anytime the degree of the top is less than the bottom, you're gonna approach 0. You're gonna have a limit going to 0, right? But let's look at this next one here. And by the way, that is the definition of a horizontal asymptote. So a horizontal asymptote, you have a horizontal asymptote anytime the limit, as you go to infinity or negative infinity of the function, if it equals a value, well then you got a horizontal asymptote there. That's that horizontal dotted line that we would draw in pre-calculus, right? And we had rules for those. In fact, let's remind you of the rules real quick that we went over in pre-calc. The pre-calc rules for horizontal asymptote. Anytime for rational functions, right? We did it for rational functions in there. If I have one polynomial over another polynomial, oops. If the degree of the top is less than the bottom, kind of like this case over here, like 2 over x to the 1, right? The degree of the top is 0, the degree of the bottom is 1, then your horizontal asymptote was y equals 0. If the degrees were the same, then it ended up being the leading coefficients, a to the m over b to the m. If the degree of the top was greater than the bottom, then there's no horizontal asymptote. And what we did in there was if it was just one more than the bottom, they could use long division to find the slant or oblique asymptote. It had a slant asymptote. Okay, and that was our rules in there. And what we're going to do now is we're going to use calculus instead to run these, and you're going to find that the rules hold, obviously, still with. So let's look at this first one here. We got the limit as x goes to infinity of 3x plus 2 over x minus 4. Well, what the idea is to solve these is we're going to divide each term by highest value of x in the denominator, okay? And that'll help us to solve this limit. So what we have is 3x plus 2 over x minus 4. So I'm looking at my denominator and say, okay, the 4, that's a degree 0. The x, that's a degree 1, x to the 1. So I'm going to take that x and divide everybody by x. In other words, I'm multiplying the bottom by 1 over x, which means I got to multiply the numerator also by 1 over x. So each of those will divide by x, right? So I can multiply the bottom by 1 over x, multiply the top by 1 over x. And let's see what happens here. I got 3 plus 2 over x over 1 minus 4 over x. Well, now as we run this to infinity, as x goes to infinity, and if you want to be technical about it, here's what we're doing. We're going to take the limit as x goes to infinity of 3 plus the limit as x goes to infinity of 2 over x over limit as x goes to infinity of 1 minus limit as x goes to infinity of 4 over x. Well, this 2 over x, 2 over a huge number, remember we're running this to infinity, that becomes 0. And this one down here, limit as x goes to infinity of 4 over x, that becomes 0. So this just ends up being 3 plus 0 over 1 minus 0, right? Limit as x goes to infinity of 3. Think of the horizontal line y equals 3. It's just 3 still. And the same thing for y equals 1, right? As we run that to infinity, stays as 1. So just 3 plus 0 over 1 minus 0 is just 3. Well, if you think about your pre-calc rules, the degree of the top was 1. The degree of the bottom was 1. So you take the leading coefficients. 3 over 1. Hey, the pre-calc rules hold, right? But again, practice this with your limit laws. We're going to run this by dividing out your denominator, largest value denominator. All right, let me get a little room here. Let's do this next one. So here's our next one. We got limit as x goes to infinity. I'm going to go write this as negative 2x plus 3 over 3x cubed minus 1. So I'm looking at my denominator, and I'm looking at that x cubed, right? That's the highest value of x there. So I'm going to divide everybody by x cubed. In other words, I do multiply the bottom by 1 over x cubed and the top by 1 over x cubed. And this becomes negative 2 over x squared plus 3 over x cubed over 3 minus 1 over x cubed. I run that to infinity. That goes to 0. That goes to 0, right? I got these constants over a huge number. It's going to run it to 0. That's going to go to 0. So we've got 0 plus 0 over 3 minus 0. 0. Which is exactly 0. Yep. Think about it with your pre-calc rules. That also works. The degree of the top, we had negative 2x plus 3 over 3x cubed minus 1. The degree of the top was 1. The degree of the bottom was 3. So if n is less than m, it's automatically y equals 0, right? Well, that's y. Now you know why. So you got the limit powers, if you will. Let's continue on with some more calculus here. On this to infinity, I got negative 2x squared plus 3 over 3x minus 1. Again, I'm only looking at the denominator, so I'm going to divide by x, right? Yeah, everybody go by that x right there. Multiply top by 1 over x, multiply bottom by 1 over x. Looks like we've got negative 2x. This goes to 0. That goes to 0. All right, so I've got this negative 2x over 3. And so at this point we say throw that negative in. So, if you want to even think about negative 2x, negative 2/3 x, right? Think about that line, if you will. What's that thing doing? That's a slope that's going down, right? So negative infinity. So I throw in a huge number here, and because of that negative out front, the negative holds, throwing in a huge number, I end up with negative infinity. This will shoot this thing to, and technically I've got negative infinity over 3, right? This one just says find the horizontal asymptote. Well, if you're finding the horizontal asymptote, you're just taking the limit as x goes to infinity. So we'll divide everybody by that x to the 3/2. this will go to 0, right? I got 1 over a huge number there. It's going to go to 0, so I'm just left with 5 over 4 plus 0. So I got 5/4. So here we're going to divide everybody by the square root of x. And the top by the square root of x. In other words, x to the 1/2. So we got limit x goes to infinity of 5x to the 3/2 over x to the 1/2. And I'm going to simplify the bottom here. So 5, I got 3/2 minus 1/2, I got 2/2, x to the 1 over 4 plus 1 over root x. Now notice this is going to go to 0, right? So I got 5x over 4. And I'm running this to infinity. So I'm going to end up with infinity, 5 infinity, right? Or infinity over 4. So just infinity. Infinity over 4 plus 0. Now this one, when I'm looking at this, you've got x and you've got this square root of x squared plus 1. So I want to divide by the square root of x squared, each of these terms, in other words, the whole thing. So but you got to be careful, right? Because if x equals x and I square both sides, I got x squared equals x squared. And then I undo that, then I have x being plus or minus the square root of x squared. So what you want to keep in mind is if x is going to infinity, then I'm going to use x being the positive root x squared. But if I have x going to negative infinity, I got to use x being negative root x squared. So it depends on what I'm going to. In this case, I'm going to infinity. So I'm going to use this one. So notice I divided the bottom by the square root of x squared. I mean, positive square root of x squared, right? I'm shooting to infinity. And then the square root of x squared is x. So I'm just dividing the top by x. Okay. And let's see what we got. We got limit x goes to infinity, 1 over. Now I'm going to put them all under the radical. So I got x squared plus 1 all over x squared, which is each of those, that's x squared over x squared plus 1 over x squared. And now we're at this point. We say, oh, well, that 1 plus x squared, when I shoot that to infinity, that's going to be 0. So I've got 1 over the square root of 1 plus 0. So 1 over the square root of 1 is just 1. So this one we've got limit as x goes to negative infinity. And notice I got a square root of x squared on the bottom. So again, I said, hey, be careful, because x is plus or minus the square root of x squared. So since we're going to negative infinity, we're going to use x being negative root x squared. That's what we got to use on this. We're doing this one, we're shooting this to negative infinity. So let me write it now. So I'm dividing by, I'm going to negative infinity, I'm going to negative root x squared. Well, that's the same as x, right? X is negative root x squared in this case. I'm going to put this radical all underneath the same radical. then x over x squared is 1 over x. So I got negative 3 plus 1 over x over negative square root of 1 plus 1 over x. Well, I'm shooting this to infinity, so that's going to go to 0. That's going to go to 0, right? And so we end up with negative 3 plus 0 over negative square root of 1 plus 0. So I got negative 3 over negative square root of 1, which is negative 1. Negative 3 over negative 1 is positive 3. All right, a few special limits you want to keep track of as you're shooting to infinity. If you think about the sine function, right, here's our sine function. Like, does it have a horizontal asymptote? Of course not, right? So it does not exist. As I shoot out, I just keep bobbing up and down. Same thing for the cosine. There's no limits for those. But if I think about the sine of x over x, if you take a look at that graph as I shoot out, pull that up for you. The further out I go, I'm going to get closer and closer to 0. It kind of tapers off, and the waves get smaller and smaller. Same thing with cosine x over x. So you want to keep these special limit as x goes to infinities in mind there, so that you can do the algebra on some of these. So let's take a look at this first one. And I would go ahead and say, well, that's a common denominator, so let me put it like that. So now I've got limit as x goes to infinity of the 1 minus limit as x goes to infinity of that cosine x over x, which we know that to be 0, right? So we got 1 minus 0, which is just 1. How about this one? Well, we know that as we go to infinity of this 1 over x, we know this is 0, right? So this interior portion, this little part in here is going to 0. So this just ends up being the cosine of 0, because 1 over x as x goes to infinity is going to 0. Well, we know the cosine of 0 to be 1, right? So that's how you want to think about that. 1 over x is going to 0, then run the cosine on that. About this 4 over 3x minus sine x. I would go ahead and say, well, largest power of my denominator is that x. Let's go ahead and divide everybody by x. And let's see what we get to. I got 4 over x. I got 3 minus sine x over x. And so we have, and I'll be technical about this. Let's go ahead and write it as that. Well, we know this is going to be 0, right? That's going to 0 right there. And this will just be 3 minus, and then there's that special limit. Let's go back up here. Remember that sine x, limit as x goes to infinity, sine x over x is 0. So this is 0. So I got 0 over 3 minus 0. So it just end up being 0 on that. All right. That's a good little, hopefully get you started, a little overview of infinite limits and asymptotes and so on. Thanks so much for watching. See you next time.